Good day, fellow students. This is Dr. Rich. Um, I want to present a short lecture on research hypothesis, and I'll just try to go fast because this is a burning issue. There are many students who are still struggling to write this research hypothesis. So I thought I should present a short lecture video to assist them in this regard. Okay, let's go. Um, the first thing first, we are going to look at the definition. A research hypothesis is a testable statement to predict the relationship between two or more variables in a study. Okay, so the thing to consider is testable. Okay, testable means that you are going to need a statistical analysis model to test the statement that you are making, right? The statement which predicts the relationship between two or more variables. So there must be two or more variables in your set before you can really apply or before you can state a hypothesis. Okay. And secondly, this is very important. The second aspect is that your hypothesis should be based or should be informed by existing scientific knowledge, theories, or research findings. So that either existing scientific knowledge, either existing research theories, or existing research findings. So what this means is that you cannot formulate a research hypothesis which is not based on some existing scientific knowledge. The basis of the relationship that you are predicting is not based on existing scientific knowledge, theories, or research finding. So remember that you state a hypothesis to predict the relationship. So what we are saying, this relationship that you are predicting, that information should be based on existing research findings. So those who are formulating hypothesis without basing it on any existing scientific knowledge, theories, or research findings, it means that you are doing some guessing. You are just guessing the relationship between two or more variables. Okay? Yeah, so you can't state hypothesis without basing the rationale behind the prediction on an existing scientific knowledge. So I can't really overemphasize that. This is very important. Okay, because that relationship you have to test it. So it's not if you state a hypothesis without considering any existing scientific information, then it means that that hypothesis is a guess. And scientific hypotheses are not guesses. Okay, now we look at the requirements for research hypothesis. Okay, these are things that you must know before you start to state your hypothesis. The first one, research variables. You should be able, or you should have identified the variables that you are going to be dealing with in your research. Okay, and we said there will be two or more variables, right? So if you have one variable in your research, then you should not be stating a research hypothesis. And there are some students who do not know the variables that are in their research. Okay, they just know that they want to do a research, but they don't know the variables that are in the research. They don't know which ones are the dependent variables, which ones are the independent variables. They don't know the type of data that they want to collect, whether it's a nominal data, whether it's a numerical data, whether it's a categorical data. Guys, before you go ahead and state a hypothesis, make sure you acquaint yourself with the type of data, numerical data, nominal data, and ordinal data. Okay? So, um, because based on the type of data, then you have certain types of statistical analysis model to use. Okay? And we are saying that you must know the statistical analysis model that you will use to test your hypothesis. This is very critical. So if you don't know about statistical analysis, surely you should take some short courses in statistical analysis or do some online courses to understand what statistical analysis are all about and what what is the rationale behind each of the statistical analysis that you intend to use before you can even start to state your research hypothesis. This is very critical. I cannot overemphasize this one. Okay, then now you want to write your research hypothesis. Okay, so we know that there's a null hypothesis, two types of hypothesis, the alternative hypothesis. So the null hypothesis will normally write it is 0. Okay, and the other one is the alternative hypothesis, which is often referred to as the experimental hypothesis, which is H1. So sometimes you find that in research proposal, we just state the experimental hypothesis. Of course, we know that the negative of it will be the null hypothesis. Okay, so that's something that you must just bear in mind. All right, now, remember I said that your hypothesis must be testable, which means there should be a statistical analysis, a test for your hypothesis. And if you are stating a hypothesis without any statistical analysis test in mind, then that hypothesis is obviously wrong, or it is simply a guess. Okay, so learning about statistical analysis is a course on its own, right? But I'm just going to show you some of the main ones, right? Some of the main statistical analysis model that we use, okay? I'm just giving you an overview. You need to go and study each statistical analysis model to know what sample size is required, right? What type of data is required for particular statistical analysis model, and what relationship can you test using a particular statistical analysis model. So the ones that I've picked, we have analysis of variance, right? So, okay, some people say analysis of differences. Yeah, we typically look at differences between two groups or two treatments. You have groups of samples that are treated differently, all right? So two or more groups, right? For t-test, we are looking at two groups. For ANOVA, we are looking at two or more groups. So typically, we deal with numerical data in the form of means, right? In the form of means. So, I mean, if you have two groups, you have mean 1, mean 2, right? If you have more than two groups, then you can have mean 3. So most of these tests, they check whether these things they are equal to one another, or there are some differences, and whether the differences are significant. And that's the basis of your hypothesis, right? You state your hypothesis by examining this relationship that I put here. Okay, to say whether there will be a significant or there will be no significant relationship, right? Or there will be a significant difference between the two, right? So that's how your hypothesis will go. So the moment I say I used to give an example to say, for instance, study hours, okay? I just use simple example, study hours of students and their year-end mark. So you have the year-end mark. So you look at study hours. So you try to find out that those students who are studying maybe 24 hours, those that are studying 6 hours. So you have two groups there. So you have a mean, a mean of the marks for those who are studying 24 hours can be a mean 1. Then the 6 hours can be mean 2. And then you want to see if there's no significant difference, or if there's significant difference between people who study for 6 hours and those who study for 24 hours in terms of their year marks. So that's an example of something that you can use a t-test to test that kind of a hypothesis. But we are still going to see example of hypothesis below, so let me not dwell too much on that. Then another statistical analysis model is association, right? Association, some people like to use chi-square, right? Chi-square. So chi-square, you only talk of chi-square when you have two variables, okay? You have variable 1 and you have variable 2, right? And variable 1 it has two categories, yeah? And this other one has two categories, right? So you see, this is one variable that has categories. This is another variable that has categories, and you want to check if there's association between the two. A typical one that we normally use is gender. If you have gender here, right, then you have male and female. That's a category. And then if for the dependent variable, you can have, let's say, uh, uh, let's say beverage choice or coffee, or let's say beverage choice. One will be taking soft drink and the other one will be taking alcoholic, something like that. So it has to be a categorical variable, then you can do the association. So those people who want to do chi-square, you must just make sure that your variables have categories. Otherwise, you are dealing with the wrong variable. And then for correlation is you check the strength of the correlation and you check the direction of the correlation. Okay, I can still use my example of study hours and year mark, right? And then a correlation will tell you if a correlation ranges from 0 to 1, right? And the direction is either plus or negative. So you see that if the study hour increases, the year mark increases, then that is a positive correlation. And if the correlation is 0.9, then it's a strong correlation. So you see, it gives you an association between the two and also gives you the direction. That's what correlation does. Okay, and then you have regression. Regression we use to predict, right? I can also use study hours and year mark. I can subject it to regression to predict whether students who study for 24 for longer hours, how many marks can they get based on the population that we have at hand, or based on a particular class. You understand? So you can use that to motivate to tell students that remember, if you study more hours, then you can improve on your year mark. So it just depends on the type of test that you want to use and the type of variables that you are dealing with. Okay. And then you also have multivariate application. So multiple uh, independent variables, right? If you have multiple independent variables, you can use maneuver, you can use multiple linear regression, and you can use PCA. Okay, principal component analysis. So just going to look about that. I just wanted to give you an overview. This is not an exhaustive list. So there are other statistical analysis models that I've not covered, but I've just given you the main ones that you can use as a starting point to study the others. Okay, now I want to show you examples of research hypothesis, right? Um, I'm just going to use the experimental hypothesis H1. Okay. This one states that reducing sugar intake will reduce the risk of developing diabetes. Okay. Okay, let's just cancel this one. So this is a hypothesis. So this person must have done some reading and this person is sure that there's a scientific basis of the reduction of sugar intake and reduction of risk of diabetes. There must be some scientific basis for this. Otherwise, you can't just state a hypothesis without any scientific basis for it. Otherwise, it becomes a guesswork, right? So now this hypothesis must be tested in scientific research, right? So how is this one going to look like, all right? So T-test means you have two groups. So I can have recommended daily intake, right? Recommended daily intake. I can see anyone who is taking more than the recommended daily intake more. I measure their blood sugar, right? Okay. And those who are below, I measure their blood sugar, right? And then I will have something like a mean one, mean two, in terms of the blood sugar, right? Then I can do T-test to compare whether there's a significant difference between the two. Or if I have more groups, maybe I can say, instead of more, I can say medium intake and heavy intake. Then I have three groups. Then I can start to do another. Okay. Now let's look at number two. The application of organic fertilizer improves the yield of mangoes compared to synthetic fertilizer. So yeah, we have organic fertilizer and synthetic fertilizer. This one is straightforward. So I have my mango plants, right? Mango plants. I'll subject them to a group of them to organic fertilizer. I subject another group to synthetic fertilizer. Then I'm going to do my yield, which is the number of mangoes, maybe per season, per tree. So I'm going to get a mean here, mean one. I'm going to get a mean two, right? And then this is my hypothesis. I know that I will use t-test to test this my hypothesis because I have two means, and this are numerical variables, right? And I can also just check whether my data is fully normal distribution, or otherwise there are other methods that you can follow to resolve that. Okay. So, but if your data is not meeting all the rules for a particular test, then you can find alternative tests that you can use to resolve your hypothesis. Okay, there are always some tests that you can use if one is not working, or if one test, if the data set is not meeting all the rules for a particular test, and then you can check other ones that can give you the to analyze the differences between the means. Okay. This is another one. Salmonella species isolated from the hospital environment are more resistant to antibiotics compared to those from food samples. This one is also two groups. I have hospital environment samples. I have food sample. So I will isolate a bunch of salmonella from the hospital, and I'll isolate another one from food samples. I can say I'll isolate 60 here and isolate 60 here. Then I'll check the antibiotic resistance, right? And the antibiotic resistance will give me, you can have numerical data, right? And then you have mean one, mean two, and then you check whether there's significant difference or not. So that's how I'm going to test that hypothesis. Okay, this one is saying there's a relationship between the number of hours studied. Okay, I gave this one, and exam scores. Okay, so remember that there's certain data set that you can use more than one type of statistical analysis model to test them, right? Like this one, we saw that we can use t-test to test this one, right? But this one, you can see that there are no groups. So you just have number of hours studied in a population where you do your sampling and you measure the scores. There are no groups. So you can't do a t-test here because there will be no mean one and mean two. You just have a set of data for hours and a set of data for exam score. So then correlation and regression are the best type of statistical analysis model for this kind of data, right? So if you state your relationship, if you state your hypothesis and you do not have groups or different treatment, then you are going in for correlation or regression, right? So that's why I'm saying that you must know what you're looking for. You must know the type of variables you're dealing with, and you must know the relationship that you want to investigate. And on top of that, you must know which statistical analysis method you want to use before you can state your hypothesis. Just imagine that you are stating a hypothesis without knowing which statistical analysis method I'm going to use to test my hypothesis. Just imagine. Then it will be like we are doing some guess. What if you state a hypothesis that cannot be tested? Because that's what I see when I review research proposal. Many students are stating hypotheses that cannot be tested, or they don't know how they are going to test it. Because if you look at the statistical analysis in model description, it's not even related to the hypothesis that is stated. So those are the problems that we are seeing. So students should understand that all the things must be in place for you to state the hypothesis. Don't state the hypothesis and you don't know which variables you're dealing with. You don't even know whether your variables are numerical. You don't even know what statistical analysis method you are going to use to test the hypothesis. So those are the things that you must watch out for. The last one, age, exercise every day, no smoking affects cholesterol level. So I can see there's age, there's exercise, and there's no smoking. So these are three variables, right? Three variables. So you can see you can do correlation, you can do regression, right? Because here also I can identify treatments, I can identify groups. So the issue of mean, comparing mean falls out. And the moment comparing mean is falling, you don't have groups for which you can compare means, then these are the type of statistical analysis. You are looking for those statistical analysis model that will give you an idea of an association. Okay, like I said, it's very important for you to understand basic statistical analysis for you to be able to do a hypothesis. If you don't understand basic statistical analysis, any hypothesis that you do will be a guess, I can assure you. Okay, so I just want to add one more information that you need information from literature to guide your way forward. You know? By the time you're doing a literature review, you are conceptualizing your problem statement, you conceptualize your research objective, identify your variables. At the same time, when you are doing that, just make sure the papers that you are reading, just check the type of data that they collected, and also check the statistical analysis model that were used in those papers, and then also just check the purpose for the statistical analysis model in those papers. It will help you to formulate your own hypothesis and to understand the type of data you will have and to understand the type of statistical analysis model that is suitable for the type of research you are doing. So you see, all those things must come together for you to get a good research hypothesis. Okay, so I think this is the end of the lecture. I wish you all the best, and I hope that with this now, you should be able to write a good research hypothesis. Bye-bye.